So today you're going to be learning about the empirical and molecular formulas. The empirical formula may or may not be the same as the molecular formula. They're not always the same, but they can be. The molecular formula will always be a simple multiple of the empirical formula. For an example, H2O2. H2O2 is the molecular formula, but the empirical formula is just HO. There are three simple steps to find the empirical formula. The first is to convert percents into grams, the second is to convert grams into moles, and the third is to divide by the smallest number of moles. And you can't round too much. You can never round too much. There is a poem that you can use to remember the steps to find the empirical formula if you wish. It's percent by mass, mass to mole, divide by small, multiply till whole. So as an example, say I have 40.05% sulfur and 59.95% oxygen. You're going to pretend that in the compound there's 100 grams and you're just going to convert the percent straight into grams. That's the easiest way to do it. So you say you have 40.05 grams of sulfur and 59.95 grams of oxygen. You're going to divide each number of grams you have by its element's average atomic mass. So you're just going to find the moles, really. So for sulfur, you're going to get about 1.249 moles, and for oxygen, you're going to get about 3.747 moles. Next thing is determine which number is the smallest. You know that's going to be sulfur's, which is 1.249, so you're going to divide both of the number of moles by 1.249. So you get, for the sulfur, you're going to get 1, obviously, because you're dividing by itself. And for oxygen, you're going to get 3. And that is close enough to 3 to where you don't have to multiply to get a full whole number because it's basically 3. Your answer would be SO3 for your empirical formula. Now the molecular formula is a little bit different. The molecular formula tells you how many atoms of each type of element there are in a compound. For example, glucose. Glucose is C6H12O6. That's the molecular formula. If you were getting the empirical formula of that, it would be CH2O. That's the smallest whole number ratio you can get, but that's not what's in the compound. Another thing to think about is, can two substances have the same empirical formula but different molecular? Yes. Yes, they can have the same empirical formula but different molecular formulas. For example, glucose and formaldehyde. Glucose has a molecular formula of C6H12O6, while its molecular formula is CH2O. Formaldehyde's molecular formula and empirical formula are both CH2O. So the way you find the molecular formula is you can actually do kind of a reverse of the empirical formula to find out how much of each substance would be in its empirical formula, and you can just multiply to find out what would the molecular be. Okay, so here's a molecular formula example. Say that you have C10H7O2, and you know that's the empirical formula, and you know that you have 318.31 grams of the compound. The first thing you're going to do is find out how much of each substance you'd have in one of the molecule. So you would take 10 carbons and 7 hydrogens and 2 oxygens, and you'd add them all together and see what that gets. So you add all of those together and you're going to get about 159.17. So you know that in one of the C10H7O2 you're going to have 159.17 grams. So how many of those go into it? If you times the empirical formula by 2, you get about 318.31. So you know that for the molecular formula, all you have to do is times the whole empirical formula by 2, and there you go. So just remember that the empirical formula is always the smallest whole number ratio and not to round too big, and that the molecular formula is how many atoms you actually have in the substance. So thank you.